Hello, my name is Jeremy, and I'll be presenting the paper View-Dependent Effects for 360-degree Virtual Reality Video. This is part of the research I did when I was an intern at Adobe with Stephen, Cuong, and Dan. First, what is a view-dependent effect? A view-dependent effect is an effect where the underlying parameters of the effect changes depending on where the user looks, making it dynamic and real-time. While a per-pixel effect is an effect that is directly encoded into the pixel, rendering it static and offline. This can be seen in standard video editors, where an effect, like a vignette, is directly encoded in the video, which causes noticeable gradients on the equirectangular frame for a particular view. This can be seen in this video, where a drastic color change happens across the frame at the effect location. While view-dependent effects are real-time, so a set of effect parameters can be interpolated and applied to the current view the user has into the scene. This allows us to remove unwanted gradients and uniformly apply the effect. This can be seen here, where multiple effects like tint, saturation, and contrast are applied to the view you see on the screen. We accomplish this by interpolating a sparse set of spatial keyframes that are embedded into a three-dimensional video space. This includes a two-dimensional location on the equirectangular frame and one temporal dimension. Each spatial keyframe then samples the parameter space at those particular coordinates. Our interpolation works by treating each spatial point, for example S1, S2, and S3, as radial basis functions. We then use these to find the optimal weights so that we can smoothly interpolate between each spatial key point depending on where the current view, V, is located. In order to facilitate real-time rendering of effects, we built a video player for Windows and iOS. The player takes in a set of spatial keyframes, determines their optimal weights for interpolation, and renders those effect parameters onto the current view of the user in real time. For our prototype player, we implemented a set of standard filmic effects that include blur, tint, exposure, saturation, contrast, and finally vignette. With these 6 effects, we can use them for not only post-production and narrative-driven purposes, but they can also be used for motion sickness, by applying view-dependent vignettes to restrict the user's view in the scene, and gaze guidance, by darkening the scene to redirect the user's view back to the primary point of interest in the video. To facilitate the authoring of view-dependent effects, we built an in-headset VR editor that allows a videographer or video professional with the ability to apply view-dependent effects to 360-degree video. One hand controls the application of effects, while another hand controls the video playback and timeline. Here we can see the 6 effects: blur, tint, vignette, exposure, contrast, and saturation, and the corresponding effect panels for fine-tuning and manipulation. The other hand controls the timeline and visualization of the effects. The effect tracks visualizes the effect parameters over time for the current view of the user. The effect overlay visualizes the effect parameters spatially across the equirectangular frame for the current timestamp in the video. Together, these provide a way for the user to see how an effect propagates spatially across the frame and temporally in time. These are all updated in real time as the user drops spatial keyframes onto the video, giving them real-time feedback for iteration and modification. To evaluate the feasibility of view-dependent effects, we conducted 2 studies. One was with a group of expert users and the other with the general audience. In the first study, we recruited 8 experts who all have worked with 360-degree video professionally. After initial onboarding, their task was to apply view-dependent effects to a 360-degree video of a rocket launch. Here on the screen, you can see how the unique color styles for participants 2 and 5 were applied to the video. Also note that these were all shot with our player in VR. The next experiment looked at the perception of view-dependent effects with the general audience. Each participant was shown a 360-degree video while an experimenter switched between the view-dependent effect and the regular video. One video from the study can be seen here, which switches between a static and dynamic view-dependent rendering of the scene. That concludes the presentation for view-dependent effects. Please see the paper for more details or contact me if you have any questions.